Hi, I was asked to solve a satellite problem, and I thought I would do this for everyone. An example of this problem would be something like a satellite takes 144 minutes, time equals 144 minutes to travel around the Earth. Um, how high is it? What is the altitude of it? Something along those particular lines. Let's, for our sake of an argument, say that this is traveling around Earth, and we're looking for the altitude. And I'll talk about the difference between altitude and radius as we're going through this particular problem. So when we're trying to solve this type of problem, we need to look at how centripetal force connects in with the idea of universal gravitation. And so we know that centripetal force is always a force caused by some other force. So in this case, centripetal force is going to be caused by the universal uh, gravity. And so we know that mv squared over r has to equal big G m1 m2 over r squared. Now, when we simplify this down, we can see here that r and r squared would simplify out. And the masses here, this would be the mass of the object. So we'll say this is mass 1, or we'll say m1 is the object, and m2 is, in this case, Earth. So m1s are canceling out in both of these, and we're left with the mass of the Earth. And so we get something like v squared is equal to big G, the mass of the Earth, divided by the radius. Now, we still probably can't solve this. There is no way to solve this at this point without other data based on the information that we have at the top left of the screen. We do know that the mass of the Earth is 5.97 times 10 to the 24th kilograms. So we have the information. We have G, we have the mass of the Earth. We're solving for the radius, but we do not have the velocity squared. So that is something that we're going to have to solve for. It's something that's missing at this point. So we do know that if this is the Earth, the satellite is traveling around the Earth, and that is approximately a circle. And so to figure out the velocity of an object traveling in a circle, what we do know is that v is equal to displacement divided by time, which is equal to 2 pi r, that's your circumference, divided by the period. Now we're getting someplace because we've eliminated velocity. The r's are going to be the same, and we're looking for the period. So we simplify this thing down one more time by doing something like 2 pi r divided by t, the whole thing squared, that was our velocity, is equal to G, the mass of the Earth, divided by R. And so we square this out. We get 4 pi squared r squared over t squared is equal to G, the mass of the Earth, divided by R. We're looking for R, so I'm going to bring R this way. I'm going to take everything else on the left side over to the right side, and that will give me R cubed is equal to t squared times G times the mass of the Earth divided by 4 pi squared. I now plug in my values for that we had at the top. So r is equal to the cube root of t squared. 144 minutes should get converted into seconds. 144 minutes is about 8,640 seconds. Make sure you do that conversion. So you would have down here 8,640 times 6.67 times 10 to the negative 11th times the mass of the Earth, again 5.98 times 10 to the 24th, all of this over 4 pi squared. Really tricky to stick this in your calculator. I would take the numerators values, multiply them together. Make sure you use the scientific notation key on your calculator. So that's the EE key. So you would put in there 6.67 E negative 4 times 5.98 E 10 to the 20 E to the 24th. Don't put the type of 10 there. 5.98 E to the 24th times the 8,640 that we started with. Get an answer. Then divide by, in parentheses, 4 pi squared, close parentheses. Once I had that answer, then I would take the cube root. That's the way I would do it, just to make sure I didn't mess something up with parentheses. But ultimately, when you do it for these numbers, you get approximately 9,100,000. So 9.1 times 10 to the 6th meters. This is the radius. So looking at a picture of this, we are looking at, this is the Earth. This is the satellite traveling around the Earth. The whole line from here all the way up, that's R. It's asking for the altitude. The altitude is going to be the distance that is in red here. So to get the altitude, you need to take the total radius of the satellite minus the radius of the Earth. So it would be altitude, AT. It would be altitude is equal to radius total minus radius of Earth. So our altitude in this case would be 9.1 times 10 to the 6th minus 6.38 times 10 to the 6th. And when we do that, we end up with a value of about 2.7 times 10 to the 6th meters. And there you go. That's how you find the altitude in this problem.